Hey y'all, good afternoon. We're gonna go ahead and get this session started. If headphone is the earphones of the color green. If they're green, that means you're on the right frequency and you can hear us okay. I know. Yeah, to make it green, just give the switch on the side one or two. You should be able to hear us. If you have any issues, just raise your hand and I'll come by and help you out with that. So I hope y'all enjoyed the keynote. We're going to pivot now to a session delivered by one of our wonderful AWS partners, Igor Alekseev. Igor is going to teach us today a little bit about generative AI on AWS with MongoDB Atlas. He will also be joining us later today at our Connected Collective Happy Hour from 5 to 6. He'll be delivering a pop-up demo on semantic search. So if you have any questions about this presentation or you want to check out that demo, please come find us at the happy hour later. And with that, please help me give a warm welcome to Igor Alekseev.
Thank you, everyone. You can hear me, right? Awesome. So I'm Igor Alekseev. I'm a partner solutions architect at AWS, working exclusively with MongoDB. You need headset. Yeah. Yeah. And switch it to green. Yes, you should be good. Okay, so we have, great. We have a busy agenda today. Mostly I'm going to focus on the, these are not notes, these are slides. We're going to focus mostly on how to add email capabilities to applications built with MongoDB Atlas on AWS. And just a quick show of hands, who is here on AWS? Okay, and Azure, GCP. Good. Okay, and just to calibrate a little bit more, who is a developer? Who is a data scientist or want to be a data scientist? Nobody. Okay. Who is product manager, project manager, executive type, follow-upper, kind of thing? Okay, cool. I think that gives me enough information. Cool. So AWS, like you've heard Sahir saying, we both partners and not partners. We compete with MongoDB, but our partnership is deep, and MongoDB is a great. Yes, it's part of the marketplace, a seller. It's part of several competencies. So recently was attained. We have several product-ready programs. I think is one of them. Recently, MongoDB started selling into public sector, so part of the competency. Also, there's tons of joint integrations, Private Link, Event Bridge, and I'll dive a little bit deeper into each one of them. So just to scare you, I have a diagram. It's a big and busy slide. This is, think of this as a bunch of architectures overlapped on top of each other. But there are there are 4 quadrants with Atlas in the middle. So you can just cherry pick. So your ingestion services are in the top left. You can pick, for example, Kinesis. Who've heard of Kinesis? Okay, great. So it could be Kinesis, could be, for example, Kafka. So you can push the data into MongoDB Atlas. Your compute can run on any of the services in the left bottom corner. So you can do a serverless application with Lambda. You can do Fargate, Kubernetes-based application. And then you will have integration with some AI services in the top. I have comprehend, personalize, and you can extract data on AWS. And that kind of gives you an architecture for an application. Next, a quick introduction to AI ML stack on AWS. So I'll start with the bottom because there are fewer data scientists here, but this is advanced data scientist kind of playground. This is where data scientists cherry pick their libraries. They have to deal with versions. They optimize for specific GPUs, for specific hardware. We have like specialized hardware, if Uranium. The middle layer is for where you have a more managed data science experience, where you have, there are notebooks, managed notebooks. You don't need to manage the dependencies, for example. SageMaker is the primary service there. SageMaker will manage the dependencies for you. And then the top layer, which I concentrate quite a bit today, is what we call AI services. These services are pre-built for specific problem. And these are the services where you don't need to have data science experience. Any developer can integrate. You just need to know the right API and a data set to supply. And it's services like, for example, Comprehend. Comprehend is our classification service. You'll see it most frequently with like sentiment analysis, where, and I'll talk about it a little bit later, but it can also do classification of your data, even including multi-label classification. Or there is transcribe service, where you can take speech and convert it to text. So what is a reference architecture? So like high-level reference architecture on of an app. So in this case, let's imagine user writes a review. It's a mobile, interacts with a mobile or web app. It goes straight to Atlas. From Atlas, it goes to EventBridge. EventBridge is our enterprise bus. So think of sources, targets, buses, rules. MongoDB Atlas can be both source and a target. In this case, it's a source. So the fact that user wrote a review is exposed in EventBridge as an event. It triggers Lambda. That Lambda interacts with Comprehend and tries to derive the sentiment. And if this sentiment is negative, for example, it will push it to Zendesk to create a ticket. Now, this is a high-level architecture. In reality, a lot of these AI services APIs are asynchronous. So you will probably most likely be doing something like this using our step functions. Anybody heard of step functions? OK, great. It's a workflow management service. So in this particular case, it's a standard polling flow. You submit the job for comprehend or translation, and then you keep polling with a certain frequency until it either succeeds or times out. And then you push it back to EventBridge, and because MongoDB can be source and target, and MongoDB Atlas, not MongoDB. That data will make it into Atlas. Now, even more complicated, because workflow step functions allow you to combine several services. So in this particular case, we use Comprehend to detect the language. Remember, Comprehend can do not only sentiment analysis, but also the classification. So it tells it what kind of language it is. It will translate to a different language, and then it will create an audio file using Poly, our text-to-speech service, and then we'll write results out. Now I'm going to pivot towards Amazon Fraud Detector, and this is a higher-level AI service. So of course, you can roll your own services. You can roll your own model for fraud detection. But since a lot of you are developers, most likely you will use something like a fraud detector. It allows you to easily add fraud detection capabilities to your app. You're enhancing these capabilities with machine learning model. And there are some benefits to it. But what does it look like? Essentially, as a developer, you're providing a data set. There's an event metadata, so there's timestamp, event ID, and a label. That's a training data set. But from your point of view, you just need to extract that data set somehow. And there are event variables. And that can be coming from, could come actually from MongoDB Atlas, where you get additional information. And this is what you supply to the fraud detector to train the model or to fine-tune the model. It's a black box to you. You don't really know what it's doing inside. It's magic. Then, once it's trained, what's happening, you instrument your app. When user performs an activity, app captures all the details, enriches them, sends them to fraud detector API, and fraud detector will score that activity and come back to you saying, well, this is fraud or not fraud. Now, how do you get the data set out of MongoDB Atlas? Many ways, but in this particular case, I chose to use Glue Studio. Glue Studio is our serverless ETL service where you can connect to MongoDB Atlas, extract data from Atlas into S3, and then use that to massage it, and then you feed it to fraud detector. The typical challenge is that MongoDB's data primarily nested, and machine learning services typically use tabular data, unfortunately. So you'll be flattening the data either in MongoDB when you're extracting it, or in Glue Studio, there is ability to flatten the data. So I mentioned already SageMaker. SageMaker allows you to prepare, build, train, and tune models, and also deploy and manage them. There are several services inside of each. So for example, ground truth allows you to prepare a labeled data set. Like in the fraud detector, remember, it was legit, not legit, fraud. This is the kind of, there's a whole service to help you with preparing those data sets. There are managed notebooks where you don't need to worry about dependencies for machine learning. It is more of a, the SageMaker is more of a, like it's a middle layer, remember? It's more of a data science service. Fully managed training, you just submit a training job. If you want to be a data scientist, you can try it out. And there's like endpoints where you deploy the model and to do inference. There are services, but one of the services under SageMaker umbrella is Data Wrangler. So Data Wrangler, it's kind of targeting, the target of the Data Wrangler is analysts, but with some coding skills. Not too many, but some coding skills. Because you can take a data set from MongoDB Atlas. You can also flatten it in Data Wrangler. You can write PySpark code. You can also write Pandas code. Who heard of Pandas? OK, great. And then you prepare the data. You can also run an experiment. It's a kind of AutoML kind of functionality where it will try several models and tell you quickly like how good your model can be trained, how good will be your model trained on the data set you've extracted. So reference architecture for using Data Wrangler, nothing super complicated. They're very similar, all of these architectures, because MongoDB Atlas is your operational layer. It stores your data. You need to stream it somehow. So in this case, for variety's sake, I chose Amazon MSK, which is a managed Kafka service on AWS. You stream it into a bucket, and then you use SageMaker Data Wrangler to build a model, and you deploy the model to the endpoint. Inference is not shown here, but there is on another slide, I'll show you how inference is done. So another service is Canvas. Canvas is completely point-and-click user interface. It's like, who've heard of Canvas? OK. So if you have analysts in your company and they cannot write code, they can only like point and click, Amazon SageMaker Canvas is perfect product for them. So it's a completely visual spreadsheet look interface where you load the data, you see it visually, you adjust columns. It will do pre-processing of the columns, one-hot encoding. Who has heard of one-hot encoding? OK, you're not data scientists. OK, good. Basically, it's a categorical data, male, female, or something. And then you encode it into an array of 0, 1. So if it's a male, it's 0. And then, male will be 1. The second will be 0, 1. If it's the other way around, first will be 0, second. Well, other way around. So that is done by Canvas. Don't need to know any of that. You can build a model as well. It's a more interesting diagram here. So similarly, here we're using $out. Who's using $out in Atlas? It's OK, interesting. So $out is a feature. It's an operator in Atlas where you can extract data to S3. You can specify the format. It supports Parquet, most popular formats. Then you can use Canvas, point to the S3 bucket, get the data out. The more interesting part here is in inference. So we're using triggers in Atlas. Who's using triggers in Atlas? OK, so Atlas has triggers, like traditional database triggers. So if something happens in a database, you can perform some action. You can attach a function to it. So in this particular case, we're using a special type of trigger. It's event bridge trigger. So the event on the database will be surfaced as an event bridge event. And so the idea is that when you have data changing in Atlas, you need to recalculate the score or whatever you're doing with your model. And in that particular case, so event is triggered, then event bridge will pick it up. It will go to Lambda. Lambda will be interacting with the SageMaker endpoint and then pushing the data back to Atlas so UI has the score, if it's whatever it is, propensity to churn or maybe some next link to click. Now, great, I'm on time. Generative AI, the most exciting stuff. Who has tried interacting with an LLM here? Great. So that's good. Then you know everything. So, yeah. All right. So on AWS, we have the easiest way to build foundational models. We have the most performant infrastructure, and we have generative AI-powered application, and we offer most flexibility. So first, we're focusing on how to make and leverage machine learning for our customers, and then we want to make sure it's the easiest way to build on AWS. And then for that purpose, we have Amazon Bedrock. It's still in preview. Who has tried Bedrock? OK, good. It's still like you need to apply to get. But basically, Bedrock, it helps you accelerate. It's a managed service. And it makes foundation models from AI21, Labs, Anthropic, Stability AI, and Amazon available via an API. So you don't need to manage infrastructure. It's all hidden away from you. It's a higher level service. You can privately customize, which is important because the data is not leaking into the model. Like if you interact with ChatGPT, you have to wonder, what did you tell it to? And it's going to be collected as a data. Yeah, really, you probably clicked. Yeah, you're part of the product. You're supplying the data. It's probably somewhere in that agreement that you clicked upon without reading. With Bedrock, because it's private. And then because it's comprehensive security capabilities, right? Because you don't want to leak the data to be leaked. So so Bedrock has curated models. So these are like not just random models, LLMs from the internet. These are the models that carefully were chosen. So there is Titan, Jurassic, Claude. Fancy names, they change every 3 months. And what was 2 was cool. GPT-2 was cool 12 months ago. 3 was cool 6 months ago. 3.5 was cool 2 months ago. 4 is cool now. OK, tomorrow will be 5. Yeah, so the point is they're quickly changing these models. AWS has its own model. It's called Titan. There are 2 models available, Titan Text and Titan Embeddings. Who has heard of embeddings? OK, so embeddings is what you need to generate that vector, to use that vector search. It basically takes whatever you have, the text, or Sahir was talking about noise from the car, although not Titan, because these are specialized models for audio, and we'll convert it to a vector of numbers. And that's what you use for semantic search. Titan Text is more for interaction with, chat-like interaction with the model. Titan Embeddings currently supports vector size with 4K of length, which is not going to work with Atlas. Pop quiz, Atlas, how many supports? It's the length of the vector in Atlas? Yes? 2K. It's currently 2K. But stay tuned. There will be new models coming out. So right now, you cannot use the Titan Embeddings. You can still use Titan Text. Yeah, some of these models can be tuned. So that means you supply an additional data set, and model will be kind of tuned to respond to based on the data in the data set. And just a quick kind of reference architecture for Bedrock. So kind of 3 pieces here. On the left-hand side, application. So you will need some sort of application. You probably already have one. Could be chatbot, could be mobile app, could be web, could be who knows. The middle is what, like in this case, I'm using Lambda to interact with the Bedrock. You interact with Bedrock APIs, and Atlas, in this case, provides you with a semantic search. capabilities. You retrieve. This is actually what is called RAG, Retrieval Augmented Generation. You get the extra context from Atlas. So Atlas is kind of like your content CDN, contents management system. You get that. It could be like customer-specific information. It could be whatever you choose to retrieve. The advantage of semantic search, of course, actually I have a demo. If you stop by afterwards, I'll show you how it works different from keyword search, but like it doesn't need a specific keyword. It can be like slightly deviated from the keyword. Now, you can also, we have also the most, we invested into most price-performant infrastructure. So we have lowest per inference cost in the cloud for running deep learning models, up to 70% lower. So this is Inferentia. Inferentia is a specialized hardware, specialized chip for producing, for doing inference of serving models. Trainium is similarly for training models. And Inferentia N2 is the newer chip where I think they bumped up the networking capabilities. And it's for 40% better price performance. This is important if your models are getting big, which is they are getting big, but also if it's Trainium, if you decide to train your models yourself, LLMs. And I have a slide there just to kind of help you understand what's going to happen. Preview, you're going to pay a lot to us. So we also have great GPU-based compute. Oops, sorry. Yeah. So NVIDIA will be up to 6% faster, NVIDIA 8100 and NVIDIA 10G. So this is, again, for data scientists who optimize it down to the hardware. Both, this is for training and inference. So if you're training yourself or fine-tuning, presumably your data comes from Atlas, and you'll be an extra process of training the model, training and deploying it. The rest of the application kind of stays the same. You just swap in your own custom model. And then we also have a generative AI-powered applications, Code Whisperer. Who has tried Code Whisperer? Actually, yeah, if you stop by, I can show you a quick demo. It's similar to Copilot. It plugs into Visual Studio Code, IntelliJ. And so if you saw in the previous diagrams, I had like application, interacts with the model. In this particular case, so the model is behind, there is another LLM in Code Whisperer. You're interacting with it not through chat, but through comments and through the code. So as you write the code, that's what is shoveled into LLM behind Code Whisperer, and then it comes up with suggestions based on what you've typed. Actually, it's pretty good out of the box, but MongoDB and AWS are working together to make it. And we also offer you flexibility. So we have a product called SageMaker Jumpstart. It's basically, you can think of it as a marketplace to find and deploy and experiment with the models. So for example, I mentioned Titan embeddings are not available. So what you'll do, you'll come to the SageMaker Jumpstart, and you'll find a model that has shorter vector length, and that's what you will deploy instead. Typically, you browse the models. You can pick one, and it will create the endpoint. It will deploy the model to the endpoint. It'll give you to play with, like a Jupyter-style notebook. Many models are available. Just there is some from Stability AI, from Alexa. Recently, we added Llama 2. That's a brand new additional. There is both publicly available and proprietary models from Cohere, Lido, and A21. So publicly available models offer complete visibility control over the model weights. Proprietary models may be more accurate, but also maybe more costly. It is also curated. It's not like any random model list, but definitely a broader selection of models than in Bedrock, for example. But with Bedrock, you get out-of-the-box API. So you don't need to put endpoint, provision in it, deploy, and then you need to write a little bit of code to wrap that endpoint call, and maybe it's a Lambda, maybe it's an API. You, with Bedrock, get ready API. You model with an endpoint plus an to play with, and the rest you have to do it yourself. So you can start it with the foundation models. You choose one of the models, you try it out, meaning you deploy, you click on either fine-tune. If there is fine-tuning capabilities, you'll see in the model description there is like fine-tunable or not. Now, this is an interesting slide. So why would you not want to train yourself? Cost. And the easy. So basically, prompt engineer, you're massaging the instructions you're giving to the model. And that's the cheap. I need to train. You just massaging the text and submitting the request. If GPT, what you're typing to prompt engineer. You are an assistant that is very verbose and you're trying to help me to generate something, whatever. So that's the prompt engineering. Retrieval augmented generation is what is very popular right now. You basically supply additional information coming from MongoDB Atlas or any other sources because you know the context. And actually in them I'll show you if without the context, the models typically hallucinate. They just make up stuff, which sounds cool sometimes, but it just, in financial environments or where you need more precise answers, you cannot tolerate hallucinations because some lawyer that tried LLM and it just cited cases and it looked very good, but it's all bogus. Then instruction fine-tuning. So you're supplying additional data to the model, and the model will get new capabilities to advantage of this new data. And you see that the cost is increasing. And the most expensive is the retraining model from scratch. So you'll be responsible for scraping the internet or whatever all your contents that you have at the company and shoveling it into a model and hoping it's enough for it to reason and kind of process the data. It's certainly RAG is much, much cheaper. So if you're start with RAG. That's easier. So this is SageMaker Jumpstart with MongoDB Atlas. Yeah, so Jumpstart in this particular case, and actually that's the bot I'm going to show at the booth later. I use Flan T5, and then I produce the embeddings. The model is deployed from Jumpstart, and same, I'm using it to provide additional context. Now, if you have, what happens when, the previous slide kind of glosses over how I got the embeddings in. Technically, what I did is I did a batch brute force for every document in the database updated. But in reality, what's going to be happening as your data changes, you will need to update the embeddings as well. So you will be calling continuously. And here I use the model Mini LM-L6 from Hugging Face, and it has I think 368 vector size, so that will work with Atlas. So whenever something changes in the application, you can expose that via event bridge to Lambda. Lambda will call the embeddings model endpoint, get the embeddings, which is a large vector, shovel it back into Atlas. And this way you will keep always up-to-date information. So how can you start your journey today? So try Code Whisperer. It's free, actually. It plugs into Visual Studio Code, super easy. You can use your own personal ID. You don't even need to ask for anybody's permission in terms of money. Models is super easy in Jumpstart and Bedrock. You deal with them in the SageMaker notebook. Just you supply some strings there, it generates for you. Next generation, like stability, AI. Proof of concept. Try something. If you the best proof of concept is if you have a large amounts of text data. This is the easiest way to try right now. Things like I have two large documents. Are they similar? How similar are they? Are they talking about the same thing? Or based on a very large document, can you, for example, figure out something? Like I did just for fun. I did SEC filing, 10Q, and I asked the model, tell me the growth in this quarter. And it was able to calculate previous quarter, current quarter, And I've just copied and pasted the table, well, like text, literally. So they're pretty smart. Great way to impress your management and get funding. Also, we have AI Case Explorer at aws.amazon.com. So try that out, see if there's like some cases resonate with you. And demo did not get embedded, so I'll show you at the booth. And yeah, that's what I will be showing you at the booth, actually. And I think we are running out of Q&A, so hopefully I'll see you at the booth. Thank you for coming.